nuclear chemistry, and no matter the type of nuclear reactions are known as transmutations. And what happens in a nuclear reaction or in a transmutation is that this process actually changes the number of protons in the nucleus. And when you change the atoms, when you change the number of protons, it actually changes the atom's identity and its atomic number. So if you take a look here, you start off with a nitrogen, and at the end of the process, you end up with an oxygen. So take a look. Nitrogen, if it's nitrogen, it has 7 protons, but if it's oxygen, you have 8. So this transmutation forced this nucleus to go from having 7 protons to 8, and as soon as you have 8 protons, it is no longer nitrogen but oxygen. Now there are many different types of transmutations, and at the simplest level, we can refer to them as natural versus artificial. Natural transmutations are spontaneous, which means they occur without being pushed or forced. It just happens naturally. So, and one of the ways that you can tell that it's a natural transmutation is, number one, the element symbol you see on the left is different than the resulting element symbol. And if it's natural, you have only one reactant. Whereas in artificial transmutations, these are not spontaneous. It's a forced process. And the reactant's nucleus is bombarded. And that is something that you will see. If you're seeing that the nucleus is bombarded, that is your clue that it is a nuclear reaction, and it is also artificial. So the reactant's nucleus is bombarded and forced to absorb the extra particles, which makes the nucleus even more unstable. So you can tell that it's a nuclear reaction because the element symbols you see on the left are different than the element symbols you see on the right, but the artificial, you will see 2 different reactants. Now the question is why do nuclear reactions occur? They occur because the atom's nucleus is unstable. And the reason it's unstable is that it lacks a 1-to-1 proton to neutron ratio. So the nucleus will fall apart to form a more stable nucleus. And when it spontaneously falls apart, we call this a nuclear decay. And it's during this falling apart, the nuclear reaction, radiation is emitted. This is the bad stuff. And the types of radiation that we will look at, there is alpha, whose symbol looks like a fish. There is beta, and there are positrons. Now, depending on the type of radiation that is given off, this is what is known as the decay mode, and shown on your table N. So this is your unstable nuclide. So this is what's going to fall apart. So this is unstable. And when it falls apart, this is the decay mode. This is the bad particle that is given off that can cause sicknesses like cancers. Okay? And when we know the type of decay mode that is emitted or sent out of the nucleus, then we can determine the new number of protons in the nucleus. So you will have to be able to write a nuclear decay mode based on table N information. The big idea to do this successfully is the conservation of mass. The total mass that you see on the left needs to equal the total mass on the right. The total number of protons on the left, you will see you should have the same proton count on the right.